Hey ladies and gentlemen, this is Miss Hummer and I'm going to be finishing up Unit 8, Notes 5 for you. So let's go ahead and get started with that. So we're trying to figure out the area of triangle ABC. Well, to figure out the area, you might want to write this down on your note sheets. The area for a triangle is 1/2 base times height. Well, right now I know the base, but I don't know the height. What I do notice about this triangle is that it is a right triangle. So I can go ahead and I can use the Pythagorean theorem to get that base. So I'm going to do that to start off with, or that height, sorry. So 12 squared plus x squared has to be equal to 20 squared. Well, 12 squared is 144. I don't know x squared. And 20 squared is 400. So now I'm going to go ahead and I'm going to try and isolate that x squared. So I'm going to subtract 144 from both sides. So then I end up with x squared is equal to 256. Now I'm going to take the square root of both sides. Now remember, we want to write out any radical we have as a nice simplified radical. Okay, lucky for us on this one, fortunately, it actually turns out to be a perfect square. When we take the square root of 256, we actually get a whole number, so we don't have to go through the process of simplifying the radical. So we end up with 16. So now I know that that length right there is 16. So now I can go ahead and I can calculate the area. So I'm going to do 1/2 times 12 times 16. And you could also use 1/2 as 0.5, and you're just going to plug that right into your calculator. And when you do that, you get 96. So the area of that triangle is 96. So I just did that by using the Pythagorean theorem and then the formula for an area of a triangle. Let's take a look at number 10. A square shopping center has a diagonal walkway from one corner to another. So let's draw that out. So here's my square shopping center. Don't make fun of my drawing too much, okay? So if it's square, both of the side lengths are the same. So I'm going to call them both x. Okay? Then it has a diagonal walkway from one corner to the other that's 70 meters long. What is the approximate length of each side of the center? Believe it or not, you can actually use the Pythagorean theorem to solve this. So I'm going to do one side squared plus one side squared is equal to the hypotenuse, because this is our right angle right here. That makes 70 our hypotenuse. Okay, now we can do this because both of the sides are the same. So it doesn't matter that we don't know either of them. We can use the Pythagorean theorem because both of the sides are the same. So x squared plus x squared gives me 2x squared, and that's equal to 70. So now I'm going to go ahead and I'm going to divide both sides by 2. So when I do that, I get that x squared is equal to 35. So now I need to go ahead and simplify that. To do that, I'm going to take the square root of both sides, and I get that x is equal to the square root of 35. Last thing I want to do is check to see if I can simplify it on 35, and all I can do is 5 and 7. Since there are no pairs available, the square root of 35 is as simplified as it gets. Last but not least, I need to check my label, and it was meters, so I want to make sure that I label that meters. And that's your final answer for number 10. Let's take a look at how the Pythagorean theorem works. Okay, so you have this drawing on your note sheet. So if you notice, there's squares coming off of the triangle. So let's kind of calculate the areas of each of those squares. So this square is 4 by 4. So this is 4 squared. This one is 3 by 3, so that's 3 squared. Okay, so let's kind of just take a look at this huge square here. It's technically going to be 5 by 5. Well, so I have a total of 16 squares that are occupied by that guy right there. So I'm going to highlight out 16 squares on here. So I'm taking care of 16 squares. Now, for this other leg here, I technically have 9 squares because that's 3 squared. So then that's 9. Right there, if you count up all those squares. So if you notice, if you take those two boxes, you add them together, you get the box of that hypotenuse. And that's why the Pythagorean theorem works. That's just to kind of give you an idea. So let's take a look at this in practice. So if the perimeter of a square 1 is 160 units. Okay, so the perimeter of this square is 160. Whoa, that is a highlighter. We don't want that, huh? Where did I go? There we go. So that's 160 units. Here, the perimeter of this one is 120. What is the perimeter of square 3? Well, first of all, before we can find the perimeter, we have to figure out what each of the side lengths is. Well, we're dealing with squares here, which means that each of the side lengths are the same. So to get the side length of square 1, we need to take 160 and divide it by the fact that there's 4 sides. That is a terrible 4. Okay, so when we do that, we end up getting 40. So this side length right here is 40. Same with 120. We need to divide that by 4 to see what our side length is, and we get 30. So this has a side length of 30. Now I want to try and find that side length, because then I can figure out the perimeter of the square since all the sides are the same. So to do that, I'm going to do 40 squared plus 30 squared, and I'm going to set it equal to c squared, because that's going to give me my hypotenuse. So 40 squared is 1,600, 30 squared is 900, and that's equal to c squared. So then we're going to add those two together, and we get 2,500. Take the square root of both sides, and I get that c is equal to 50. So again, it turns out to be a whole number. So this side length here is 50, but that's not actually what the question is asking me. It's asking me the perimeter, so I need to take into account that each of these side lengths are 50. So I need to add up 50 4 times. And when I do that, I get 200 units. So the perimeter of square 3 is 200 units. So that concludes this video, so you can go ahead and move on your homework, and thanks for listening.